Electricity and plumbing students, this is Mr. Voigt. I told you I'd make a video on how to wire a four-way switch. This is what you're going to have to do for a grade for me. Um, Again, we've been through this. I really need people to pay attention. The logic is not that hard. There get to be a lot of lines on here eventually, but conceptually, this should be pretty easy. Okay, even though it looks really busy at the end. Anyway, to begin with a three-way or four-way switch circuit, let's review. First off, a three-way switch circuit is anytime you have two switches, this one and this one, that control something that needs electricity. In this case, it's these two lights up here, here, and here. Okay. Now, this, if it was just this switch and this switch, those two switches, and then the lights, we'd have a three-way switch circuit. But since we have these two switches in the middle, this one and this one, that get added to this switch circuit, then it's now called a four-way switch circuit. We could only have one here. It would still be a four-way switch circuit. So you'd have one here and then the two three-way switches. See, this is a three-way switch. There's my common, and there are my two traveler terminals. On my four-way switches, traveler terminals, travelers, travelers, and on my other three-way, travelers, common. So any four-way switch circuit is going to have at least one four-way in the middle, and it can have unlimited amount of four-way switches in there. So anywhere between one and unlimited, infinity. They are always going to be stacked on the outside by two three-way switches. Okay, that is what we call a four-way switch circuit. A three-way switch circuit is just the two three-way switches and then whatever they're powering. Okay, so that's the difference. I don't make you draw out the three-way because you have a three-way switch circuit embedded in your four-way switch circuit. So we just test on this one. Anyway, in a three-way or four-way switch circuit, the first thing you're going to do, they also are called switch loops sometimes, is you're going to take your incoming power. So I have black in my hand here. So the black is my incoming power. So there's going to be a black insulated wire in this cable. And we're going to draw it from here, and we're going to take it to our common terminal. That is our power coming into this entire switch circuit. All the electricity comes in on that one wire. Then over here, all the wire is going to go out to what we're powering, which are these lights, right? On here. And that's going to come in right there. Okay. So you always have to get power into your circuit and then the power out to what you're powering. It could be opposite. This could be coming to this switch, and then your power could be coming out of here, but it's got to be, one on one side and one on the other. So that's always how you start doing these. And that is the hardest part. The rest of this, you've done the wiring up here. You should know that pretty good. And down here, it's just connecting travelers typically. So follow me here. Okay. The next step, so we got our power in and we got our power out over here. So let's go ahead and finish our power going up here. So we're going to have power coming here. We're going to have power coming right there. They're going to come together. And then that is going to have a pigtail coming off in it to power our light. Then over here, we're going to have power coming off of this one to power our light. Okay. So power will come in all the way over here, and somehow it'll get all the way through all these switches and then up through this little system here to power everything. Okay. That's all we need with the black. We're going to do our orange is going to represent our neutral. So when we come in here, remember, these are mechanical switches. We do not need neutral switches or neutrals to mechanical switches. Okay. So they just tie together in all these boxes. So you might ask, well, why do you need neutrals at all if you don't tie them to the switches? Well, these will need neutral wires. So we're going to come here, and this will come down, tie together right there. And it comes up, and these are our neutral wires, right? But this light needs to be able to get back to ground, or back to its source. So the electricity will come through all these. It'll go up into this light, through the light, power the light, and then out and back down and through all these wires to get back to its source. You have to have a complete circuit. Everybody knows that part. You've learned that in science class when you're a little kid. But somehow we want to forget it when we get into an application that's real. I don't know why. It must be confusing, obviously. So anyway, that's our neutral side. That's it. That's all there is to the neutral side. The ground side is the same. The only difference is, so I'm going to come here with my ground. I'm going to come here with the ground. Instead of having everything needs a ground, right? So we come off and go to our switch with our ground. Over here, we're going to come down with the ground. We're going to come down with the ground. We're going to come up to our light with the ground. We're going to come down with the ground. We're going to come down with the ground. We're going to come up to a ground. We're going to come over to here with the ground, over to here with the ground, give it a thing. Boom. Up here, same thing. Okay. And then we're going to come out. We're just going to connect it to the light. And over here, just connect it to our light. We're going to assume those have grounds on them. Okay, most lights have grounds. That's it. It's the same thing except for you pigtail to each switch because you want a ground on your switches. Okay, so you do your power. Now the only other thing we have to do is our travelers. So we have a traveler wire that's going to go from this terminal. How this works is these terminals are going to connect to this. Then you have another set of travelers that will connect to this and another set of travelers that will connect to this. All you got to do is get a pattern going here. So I'm going to go red. The only difference is I'm going to go red to here. It's going to go through this wire and it's going to come out here, right? And I want to keep it on the same side right there. Okay. This one then is going to come out and it's going to go in there. It's going to go through here. It's going to come out and it's going to go right there. We're going to come out here. There. We're going to come out here and it's going to go right there. So that's it. My traveler, basically this travels through here to go to there. And then here, I'm going to go through here to go to there. Then here, it's going to go to there. See how I went top to bottom, top to bottom, top to top? Just on this last one, you just go to what's there. So then you're going to do the same thing with the black wire on the other travelers, right? So this is going to be this traveler. It's going to come out. And this is going to go to my top here. And this one is going to go to my bottom. Okay, it comes over. My black here goes to my top. My black here will come all the way around and go to my bottom. Come over here. It will come all the way and go right there. Now that looks like a mess. I understand that when you look at it, you get confused. That's why, and this is where I think many of us go wrong. We don't want to take the time to sort it out. Okay? I don't know why, but you just don't. Or a lot of us don't. And I don't really have a good answer other than the fact that you got to sort it out. It's just that complicated. So if you come in here, let's watch this for a second. My electricity will come into here, go to there. It's either, and I'm going to go ahead and ruin this. It's either going to, when this switch is in one position, it will go like this. And I might as well do this with a pencil so I can erase it, I guess. The other way it would connect would be like this, right? It's either going to be, so it's either going to route the electricity up through this wire or over to that wire, depending on what position it's in. These switches, it's either going to route it. So the electricity, let's say it's going up through this red wire, and then it will come down, right, through here, and it will come in here. It will either route it down to that one or down to this one, depending on what position it's in. Okay. And if it comes down, let's say it's in the position where it comes down here, then it will come down here, over, it'll come out, and it'll come up here, and it'll do the same thing here. It'll either route it down to there, or over to there, depending on what position it's in. Let's say it's in this position. It comes over to here, goes down through the black one, over to here, and up to there. And depending on what position this is in, it could be like this, or it could be like this. Let's say it's in this position. So this electricity stops right there because this switch is in this position. This isn't here. There's nowhere for it to go. It stops right there. These lights are now off. And what happens is anytime you trip one of these, it will reroute the electricity. So now if I flick this switch, it goes from having these two connected to having these two connected. All of a sudden, this electricity jumps down here, goes up through this wire, right? And goes out and lights this light, goes out through this wire and lights this light. And then it goes back through my neutral side. So these will look like this, right? These wires will either be crossed like that, or they'll connect the same side. This will either go across like that or down to the other terminal. And you can do that over and over and over. And every time you move, which way it goes. If electricity is coming in here, if it goes down there, or it goes down there, depending on how that light switch is situated. And it will change whether electricity is getting out this side of the circuit or not. It works if you go through and do it. So anyway, that's what this is. Study this, practice it before your test. Okay.